You have been coding for years and one day you write two lines that look completely innocent. You take an object, you set a second variable equal to it, you change a field on what you think is the copy, and then you print the original and it has changed too. What just happened? This is the assignment trap. In Python and most modern languages, the equals sign does not copy objects. It creates a second name that points to the exact same place in memory. To get a real independent object, you have to clone it explicitly. In this video, we will break down exactly what cloning is, when a shallow copy is enough, when you need a deep copy, and how to make the right call every time. You write backup equals user and you feel safe, but memory tells a different story. There's only one dictionary in RAM. Both user and backup are just labels pointing to it. When you mutate user, the change appears through backup too because they are the same object. A true clone is a second distinct object in memory. Mutating one leaves the other completely untouched. The fundamental question in cloning is not which variable do I use, it is how many objects exist in memory. Assignment never creates a new object, only an explicit copy operation does. Every bug in this space comes down to forgetting that distinction. So what exactly is cloning? Cloning means creating a new object that starts with the same data as an existing one but lives at a completely different address in memory. From that point on, the two objects are independent. You can change one without affecting the other. This is different from aliasing, which is what assignment gives you. An alias and the original share the same memory. A clone does not. Python gives you two built-in tools for cloning: copy.copy for a shallow clone and copy.deepcopy for a deep one. The difference between them is not in the top-level object, both create a new one, but in what happens to the objects nested inside. A shallow copy creates a new top-level object but does not recurse into nested structures. So if your object contains a list or another dictionary, those inner objects are still shared. Call copy.copy on a dictionary with a name field and a tags list. You get a new dictionary. But the tags list inside is the same list object in both the original and the copy. Append to tags through the copy and the original sees it too. Shallow copy is safe for flat objects where every field is a primitive like a string, an integer, or a boolean. Those are immutable, so sharing them causes no problems. The moment your object contains any mutable nested structure, you need to think carefully before choosing a shallow copy. A deep copy solves the sharing problem by recursing into every nested object and making independent duplicates all the way down. Call copy.deepcopy and you get a completely separate object tree. The original and the deep copy share nothing at all. You can mutate tags in the deep copy and the original tags list is completely untouched. The trade-off is performance cost. Deep copy is slower than shallow copy because it has to traverse the entire object graph. For large or deeply nested structures, this overhead can be significant. But for correctness across threads, across process boundaries, or in any situation where you hand data to another caller and never want surprise mutations, deep copy is the right tool. Choosing between shallow and deep comes down to three questions. First, do your top-level fields contain any mutable nested objects? If no, shallow copy is safe and fast. If yes, move to the second question. Second, will the receiver ever mutate those nested objects? If no and the nested data is effectively read-only, shallow copy is still safe. If yes, you need deep copy. Third, does performance matter enough to change the approach? Sometimes you can restructure data to be flat and sidestep the problem entirely. Shallow is fast and low memory but shares nested references. Deep is slower and uses more memory but gives you complete isolation and full mutation safety from any direction. Not every type needs cloning at all. Python types divide cleanly into mutable and immutable. Immutable types like integers, floats, strings, tuples, and frozen sets cannot be changed in place. You can share references to them safely because no one can mutate them under you. Mutable types like lists, dictionaries, sets, regular objects, and byte arrays can be changed in place. Anytime you pass a mutable object to another function or store it somewhere else, you are handing over the ability to change it. Cloning is the mechanism by which you say, here is your own copy, do whatever you want with it, you cannot affect my original data. Understanding which types are mutable is the foundation of knowing when you actually need to clone. Real systems clone for specific practical reasons. An undo and redo system needs deep copies of application state before every mutation so it can roll back to any previous point in history. A configuration system deep copies its default config before applying user overrides so the defaults survive repeated use across many callers. API response cache can usually shallow copy response dictionaries because the cache data is read only after it is stored. A concurrent system that passes data to worker threads or subprocesses needs deep copies to eliminate shared mutable state and prevent race conditions. A prototype pattern clones a template object to avoid paying expensive construction cost on every new instance. The right copy depth in each case follows from whether the data is mutable and whether the receiver will modify it. The decision is simple once you see the object tree clearly. Start by asking whether you need an independent copy at all. If not, just use assignment. If you do need independence, ask whether the object has nested mutable objects inside it. If the structure is flat, a shallow copy with copy.copy is the correct answer. If the structure has nested mutable objects that the receiver might change, a deep copy with copy.deepcopy is what you need. In Python, those are the two tools. In other languages, the same pattern applies even when the API looks different. Always prefer the simplest copy that gives you the isolation you actually need. Overcopying wastes memory and time. Undercopying creates subtle bugs that only surface when two callers unexpectedly share mutable state. Thanks for watching.